Okay, so this year we've been talking about quadratic forms. There are 3 types of forms that a quadratic could be written in. And so I'm going to review those with you and also talk about how we can get key information from each form and use that to come up with a graph. So the first kind of form is standard form, and it looks like this: y equals ax squared plus bx plus c. And we can take A and B and use them to find the vertex. So if we take the opposite of B divided by 2 times the value of A, that's going to give you the x value of your vertex. Once you know the x value of the vertex, you're going to plug that right in to your x value, and you can find the y value of your vertex. The other key piece of information you might find in standard form, it's the easiest piece of information to find in standard form, is your y-intercept, because if you were to plug in 0 for x, that would go ahead and cancel out this term, and 0 times b would also be 0, and so that would leave you with c, which is your y-intercept. So in standard form, c is your y-intercept because plugging in 0 cancels out all your other terms. The second form is vertex form, and it looks like this. And you are going to be able to very quickly see the vertex from h and k. And one thing we talked about is that because it says x minus h, we have to be very careful in finding out what h is. That means if it says x minus 3, your h value itself is 3. So you have to be careful with the signs. So we can quickly see our vertex in vertex form from h and k. And then our y-intercept is no longer as easy to see. And so in order to find our y-intercept, we're going to have to take 0 and substitute it in for x, and then simplify. And then our final form is called intercept form. In intercept form, we can see the x-intercepts in P and in Q. And so again, just like we had with H, we have to be careful with the sign. If it says x minus 3, then that makes P 3 because the x minus is already a part of the form. So we can see our 2 x-intercepts. And then once we have our x-intercepts, we can go ahead and find a couple things. One thing is the vertex. If we have an x-intercept here at -4 and another x-intercept here at +6, we could find the vertex by counting to the middle. So there's 10 across, so we need to go 5. 1, 2, 3, 4, 5. And so our vertex has to be here on our axis of symmetry in the middle, because it has to be symmetrical across that line. Another easy way to figure that out is you don't have to count. You could say, okay, well, we have -4 and we have 6, and we're going to average those. -4 plus 6 divided by 2. And that's another way we can get this x value of 1. So that would give us the x value of our vertex. And then again, just like before, in order to get the rest of our vertex, we have to plug it in for x and simplify. To get the y-intercept, just like with vertex form, we can't see it straight out, so we have to take that x equals 0 and plug it in and then solve. Now what about A? You'll notice that all 3 forms have A, and that's because A is affecting the graph in the same way in all 3 forms. So in all 3 forms, A is doing 2 things. The most important of the 2 things that we're going to talk about is that if it's positive here, it's going to open up, and it's going to therefore have a minimum value. It's going to not go below the vertex, so that's its minimum. If the A is negative, it's going to open down, and therefore it has a maximum value. It has this highest value that the graph reaches. The other thing A is doing that we talked about is it's affecting whether the graph is looking wide or looking more narrow, and that's because it's stretching it like a rubber band vertically. And so if you take a rubber band, you hold it on its top and its bottom, and you pull, it's going to stretch it out vertically, and that's going to make it look more narrow. And if you take some Play-Doh in between your hands, you're holding it in between your top hand and your bottom hand, and you push on it, that's going to make it look more wide. So A is also affecting whether it looks more narrow or more wide. So let's do an example. This example is in standard form. From standard form, we should be able to always find the vertex, the y-intercept, and then any other points that we decide we need. So the first thing that we're going to do is we're going to find the vertex. And so to find that vertex, we're going to use negative b over 2a. And so our b value is positive 4, so we take the opposite of b, negative 4, over 2 times a, and here's our a value of negative 2. And we're going to simplify, and that gives us negative 4 over negative 4, which gives us positive 1. So that tells us the x value of our vertex. To get the y value of our vertex, we need to plug it in for x. And when we simplify, that gives us negative 2 plus 4 minus 5, which is negative 3. And now we have our vertex. So that's a key part. We want to start by finding our vertex, and that's 1, negative 3. Once we graph that vertex, that also gives us our axis of symmetry so that later we can reflect key points over it. We also are going to want to find our y-intercept, and to do that, we are going to plug in 0 for x, and if we did that, that cancels this term, and that leaves c of negative 5, which is our y-intercept. So I can graph that c value, which is our y-intercept. Once we do that, we can also reflect it over our axis of symmetry. So over here, it's 1 to the left of our axis of symmetry, so we can go 1 to our right of our axis of symmetry and draw that marking point, that matching point. So there's our matching point. Now we can kind of start to see the graph of this parabola, but I really feel like we could use another point. So I'm going to pick either, we have the value at 1, we have the value at 2, so I'm either going to pick 3 or negative 1. And for some reason I feel like negative 1 will be an easier point to plug in. It doesn't matter either way, but let's plug in negative 1. So we see we have negative 2. Negative 1 squared is positive 1. We have minus 4 minus 5. So that gives us negative 2 minus 4 minus 5. So that gives us negative 11. So that gives us another point, negative 1, negative 11. So we can plot that, negative 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I can plot that point. There we go. And that gives me another point to plot because it should be symmetrical. And so I can plot its match over here. And then I can draw in a smooth curve as best as I can. You guys will hopefully do a better job than I will. And there we go. We've graphed it. To graph this equation, this one is in vertex form. So we can get our vertex here from HK, keeping in mind that vertex form looks like this. So we have to say, okay, well, if we were to rewrite this as x minus something plus something else, in order for that to say x plus 1, it would have to say x minus negative 1. That's how we would get x plus 1. So that is our h. And then again, to get it to say x plus something, it would say x plus negative 4. That's our k. So that gives us our vertex, which is negative 1, negative 4. So the vertex is the first thing that I'm going to get, negative 1, negative 4. And there's my vertex, which means that is also my axis of symmetry. Once I have my vertex, I need to get some more points. I always like to go for the y-intercept. Unfortunately, with vertex form, we don't have a C value. We don't have a way to look and see exactly what the vertex is. So because of that, we're going to have to go ahead and just calculate it. And the way to find the y-intercept is to find out, well, what is y when x is 0? Because that's what a y-intercept is. A y-intercept is on the y-axis, and that means x has to be 0. So if we do that, we have -3 times 0 plus 1 squared minus 4. And so that's 1 squared. So we have -3 minus 4, which is -7. 1, 2, 3, 4, 5, 6, 7. So there is our y-intercept. And then we can also graph that matching point. So 1 to the left and also down 7. And so that's looking pretty good. If I thought to myself, man, I really think I should have another point, which it seems like that might be the case, what I might do is go ahead and plug in one more point. I'm going to pick 1. And you can pick any point. I'm just thinking that another point over here would be helpful. So I'm just picking 1, but you could pick 2 or -3 or, you know, something that we haven't done yet. And so that gives me -3 times 2 squared minus 4. So that gives me -3 times 4 minus 4, which is -12 minus 4, which is -16. So that gives me the point of 1, -16. And that's going to be kind of tough to get on my graph, but I'm going to do the best I can. Let's see, 1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And so there is my extra point. And then I can graph its match, which is going to be in the way of my writing, but that's okay. And there's my graph. So it's important to note that in vertex form, you can quickly get the vertex from H and K, just making sure you're being careful with the sign on the X. And then once you have the vertex, you're just finding some extra points. The y-intercept is always a good one because plugging in 0 usually is a pretty efficient number to plug in. Okay, and then the last problem I have here is in intercept form. And so the first thing that I'm going to do when I see that it's in intercept form is I'm going to write down my x-intercepts. And just like before, I want to remember that intercept form already has the minuses in there, x minus p, x minus q. So if I keep that in mind, x minus 5, 5 is p. But over here, if I write x minus something, that's going to be x minus a -1 to make that a +1. So I have 2 x-intercepts. That's 5 and -1. And I'm going to go ahead and graph those. And so I have 1, 2, 3, 4, 5, and -1. So I found my x-intercepts. The next 2 things I'm going to want to find are my vertex, first and foremost, and then if I need some extra points, maybe a y-intercept. There's 2 ways that I can go ahead and find that vertex. The first way is to just look at this and count to the middle. So we have, starting here, we have 1, 2, 3, 4, 5, 6 to move over. So that makes the middle 3. So I'm going to go 1, 2, 3. So that's right here. That's when x is 2. Another way to do that especially if you're working with fractions and then all of a sudden finding the middle becomes more complicated, is to average your two x values. Add them together and divide by 2. And so that gives me 4 divided by 2, which is 2, which is what we got when we counted the middle. So I know the x value of my vertex is 2. I don't know the y value, and so that's when I'm going to plug that x value in to solve for y. So I get a -1 times -3 is +3 times 3 is 9. So 2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my vertex. Okay. And then to be really thorough, I also am going to find my y-intercept. And again, just like with vertex form, I can't just see my y-intercept. So I'm going to have to plug in 0 for x. So I get my y-intercept to be 5. And so 1, 2, 3, 4, 5, there's my y-intercept. And I can use some symmetry and notice that it's 2 over from the axis. So I can go 2 over and mark its matching point, which is right there. And so now I've drawn my parabola. One last thing to know how to do is to switch your quadratic that's in vertex form or in intercept form and put it into standard form. The best way to do this is to use however you like best to multiply out two binomials, whether you like the FOIL method or the box method, or you just like to keep track of your distribution. But one common mistake I see is people wanting to take this squared and just make this x squared plus 1 squared. And you have to remember that squared means multiplying it by itself. So we are always going to take that and write out x plus 1 times x plus 1, because that's what squared means. And so you won't get the same thing if you just square x and square 1. So now this is what I meant when I said if you like FOIL or if you like the box method, however you like to make sure that you are properly distributing these two terms to each of these two terms. And I like to just go in order and say, okay, well, x times x, that's x squared. X times 1, that's 1x. And so now I know that my first x has been multiplied by each of the other two. And now I'm going to multiply my 1 by each of the other two. So 1 times x and 1 times 1. And then I'm going to bring down the rest of my problem, making sure not to leave it behind. And so I've now multiplied that out. I am going to combine my like terms, because 1x plus 1x is 2x. And now I'm going to distribute my -3 to each of those terms. So that's -3x squared minus 6x minus 3. And then I'm bringing down that -4. And I have one more like term to combine. And that's -3 and -4 to make -7. And now I've written this original quadratic, and I've taken it from vertex form, and I've put it into standard form. And you can do that as well with x-intercept form. So, at the end of this video, you should be able to take any of the three forms. You should be able to take any of them and find the vertex. So one method uses -b over 2a, that's for standard form. For when it's already in vertex form, you're looking at hk. And if it's in intercept form, you're averaging the intercepts. You should be able to find the y-intercept in any of these three forms. And that means in the first one, it's straightforward, it's C. That's in your standard form. And in vertex form or in intercept form, you're going to have to substitute 0 for x. And then you should be able to sketch a graph from any of the three forms. Particular to one form is the intercept form. You should be able to find the x-intercept. And then you should be able to as well take intercept form or vertex form and convert it into standard form by distributing or using FOIL or your box method, whichever method you like. So when we're looking at this, those are the things you should be able to do at the end of this video. Graphing from all three forms, finding the vertex from all three forms, finding the y-intercept from all three forms, finding your x-intercepts from intercept form, and putting any of the intercept or vertex equations into standard form. Don't forget to come see me for help. Good luck.